A mouse moves back and forth in a straight line, attracted to bits of cheddar cheese alternately introduced to and removed from the ends at the right and left of the tunnel. The graph is of the mouse's velocity, which is speed but with a sign, whether it being positive moving to the right, negative moving to the left. And assuming the mouse starts t equals 0 at the center of the tunnel, we're going to use the graph to estimate a bunch of stuff here. When does the mouse change direction? So if positive velocity means moving to the right and negative means moving to the left, then when you switch from positive to negative or negative to positive, the mouse is changing direction. So that happens here and here and here. So at about 17, 23, and 27 seconds. When is the mouse moving most rapidly to the right and to the left? So that would be the maximum and minimum velocities. So this point right here, that is the highest velocity on the graph. So that's when it's moving fastest to the right. So that happens at about 10 seconds. And then when it's moving fastest to the left, that's going to be the lowest point on the graph, which is right here, t equals 40 seconds. When is the mouse farthest to the right of center and farthest to the left? Well, he starts at the center, and when his velocity is positive, he's moving to the right. So here he's moving to the right, moving to the right, moving to the right, and he is moving to the right for a full 17 seconds before he turns around and heads back to the left. So then he goes back to the left for a while, then he moves right, but for a very small amount of time. Smaller than the amount of time that he spent moving left. Okay, so he is furthest to the right after 17 seconds. Because then he moves left a good amount, like this area is larger than this area. So even though he goes back to the right again, it's offset by how far he had moved to the left in between. And then he has moved furthest to the left. He is the closest to the left end of the tunnel at the very end, because here he's moving right, then he's moving left, so he heads back towards the center, but he doesn't even get to the center because this area is much smaller than this area. Then he moves right again, then he moves left for the rest of the time. So when he gets to the end here, that's when he's moved the furthest to the left. Okay, what is the mouse's speed or magnitude decreasing? Magnitude of velocity, when is that decreasing? So when it's positive, velocity is speed, right? So here he's at a maximum speed and it decreases until it hits 0. So the mouse's speed is at a maximum at 10 seconds. Right? But then after it hits 0 here, he turns around and he starts speeding up. He is actually moving and speeding up until right here, and then he's slowing down as he comes back towards 0. So this, even though it looks like a minimum on the graph, it's a minimum for velocity, but it's a maximum for speed. So the mouse's speed is decreasing anytime we have an extreme, a peak, and we're heading towards 0. So 10 seconds to 17 seconds, decreasing. And then 20 seconds to 23 seconds, it's decreasing. And then this looks like 24.8 to 27 seconds. And then from there, it's just speeding up again. When is the mouse at the center of the tunnel? So t equals 0, that's where he starts. 0 seconds, he's at the tunnel. So now I need to estimate when he has traveled equal distances to the right and to the left. So we're looking for the area under the curve above the x-axis and below the x-axis to be equal. So if I shade the area above, and I want to shade area under the x-axis until I feel like I have reached an equal amount that I just shaded in pink. So green, I'm definitely not there yet. That definitely looks less than the amount of pink area. So I'm going to shade some more until I feel like I've gotten equal amounts of area. This is very rough. We're going to say about 38 seconds. Okay, suppose f is a function where f of 0 is 10, so I've put that into the table, and I have a graph of f prime of x, and I want to calculate all these values of f. So I'm going to use the fundamental theorem, where I know that the integral from 0 to 1 of f prime of x dx, that's the area under the curve from 0 to 1 of f prime of x dx, that is equal to f of 1 minus f of 0. So I need to calculate this area under the f prime curve from 0 to 1. So that's this. So that is 1, that's 1, and then this triangle is 2 by 1, so it's 1. So that all that area is underneath the x-axis, so that's -3. F of 1 I don't know, and f of 0 is 10. So if I solve for f of 1, I get 7. I just add 10 to both sides. And then I'm just going to keep doing this for each interval. So I would set up a very similar thing from 1 to 2. I'll do one more, and then I'll leave it for you to finish on your own. So the integral from 1 to 2 of f prime of x dx should equal f of 2 minus f of 1. And the integral from 1 to 2 is the area under the curve, which looks like it is 1 by 2, so its area is 1. It's under the x-axis, so it is -1. F of 2 I don't know. F of 1 is 7, so I'm going to add 7 to both sides, and I get f of 2 is 6. And you would just continue doing these calculations to get the last 4 entries we're looking for there. Suppose that f is a function where f of 0 is 0 and f prime of x is 12 minus 3x squared. Use your calculator to estimate f of 1. So this is another fundamental theorem question. So I know that the integral from 0 to 1 of f prime of x, which is 12 minus 3x squared, dx should be equal to f of 1 minus f of 0. Okay, I'm looking for f of 1, so I'm going to be solving for that. F of 0 is 0. That was given. And then this integral value I can get using a calculator. So you press the math button, you scroll down to number 9, function integral, and I'm integrating from 0 to, oops, start again. Option 9, integrating from 0 to 1 of 12 minus 3x squared dx. And we get 11. And that adds 0 to both sides. That's silly, right? So it turns out that f of 1 is 11. Okay, so I want to complete this table using the same method from part A. So I now know that this is 11. And then f of 2 I can get by integrating from 1 to 2. the integral from 1 to 2 of 12 minus 3x squared dx equals f of 3, f of 2 minus f of 1. So I have to get my calculator to tell me the integral, the area under the curve. So I can hit second enter to just pull up exactly what I just had, and I'm going to change the bounds from 1 to 2. And we get 5. So 5 equals f of 2, don't know, minus f of 1, which is 11, which means f of 2 is 16. Continue on with this for 3 more values. Try to find a function f whose derivative is 12 minus 3x squared and evaluate at 0, 1, 2, 3, 4, and 5. Check that our table above is correct. Okay, so a function f whose derivative is 12 minus 3x squared could be 12x, because the derivative of 12x is 12, and the derivative of x cubed is 3x squared. So f of x is 12x minus x cubed. So let's check f of 0. If I plug zeros in for x's, I get 0, so that works. That matches my table. And then f of 1 would be 12 minus 1, which is 11. That matches the table. And then f of 2 would be 12 times 2 minus 2 cubed. 24 minus 8 is 16. That matches the table. And the other 3 will also match.